In this session, we will talk about some basic terminologies used in machine learning. I am having a car and I am thinking to sell my car, so I want to know the approximate resale value for my car. Car's resale price depends on many factors like which brand, which model, how old the car is, how much it drove, fuel type, whether petrol or diesel, car type, whether hatchback or sedan or SUV, transmission, whether manual or automatic, etc. This is just an example of dataset where we have just considered few factors. Using this dataset, machine learning can train a model and predict price for a car which is not present in the dataset. Can you tell what type of learning is this? Yes, this is supervised learning. Reason is target value, which is price in this case, is present in training dataset. According to this example, age, kilometer driven, fuel type, car type are input variables and price is output variable or dependent variable. Usually input is denoted by X and output is denoted by Y. As Y is dependent on X, there would be some mapping between X and Y. This is denoted as Y is a function of X. And machine learning's objective is to find out that function or statistical relationship. And this function is also known as hypothesis. Hence, Y can be denoted as h of x. If one variable can be accurately expressed by another variable, then these two variables are having deterministic relationship. For example, if we know temperature in Celsius, we can accurately determine the corresponding temperature in Fahrenheit. Then what is statistical relationship? Statistical relationship is where accurate relationship between two variables cannot be determined. For example, relationship between number of hours studied with marks obtained. Okay. Now age, kilometer driven, fuel type and car type are told as features in machine learning. And for say we are having 100 data row in this dataset, that means number of training set is 100. Usually it is denoted by small m. Let's look back to the sample dataset once again. Here values for variables like age, kilometer driven, price are continuous. That is, we cannot count the number of different possible values. But fuel type's value can be either petrol or diesel for this dataset. This type of variable is named as categorical variable, which can take on one of a limited possible values. Can you guess if car type is continuous or categorical variable? If you said it's categorical, you are absolutely right. Value for car type can be any value from a list like hatchback, sedan, SUV. These categorical values are not numeric, and some of ML libraries do not take categorical values as input. Hence, we need to convert them into numeric. But how can we do this conversion? There are various options, but most commonly used approach is one hot encoding. Let's check briefly how this works. Instead of categorical variable, a new binary variable will be added for each unique category. In this example, for fuel type, we have considered only two categories. Therefore, as part of one hot encoding, two variables will be introduced. Then one will be placed in the binary variable for that fuel type and rest variables will be 0. Similarly, car type can be converted like this. Let's check y equals to h of x. How can we obtain the mapping using machine learning? To see this data on graph, we will require 5 dimensions, which is not visually representable. So to keep this example simple and understandable, we have only kept kilometer driven and price. From this graph, we can find a negative relationship between x and y. That means if kilometer driven increases, price decreases, and vice versa. Before jumping into more complex algorithms, I am going to explain some basic concepts using linear regression, which is used to find linear relationship between target and one or more predictors. Coming back to the graph, these data points can be fitted through any polynomial function, but for simplicity we are trying to find the best fitted line. Best fit line is the one for which total prediction error will be as small as possible. As we already know, equation for a straight line is y equals to mx plus c, where m is the slope and c is the intercept. To get the best fitted line, we have to find out m and c based on given x and y. M and c are called parameters in machine learning. As parameters are denoted by theta in machine learning, we can write the equation like y equals to theta 0 plus theta 1 into x. It will initialize theta with some random value and get a line. Now we need to measure how wrong the model is in terms of its ability to estimate the relationship between x and y. This measure is known as cost function. Smaller the cost function means better the model. For linear regression, least square cost is used as cost function, which is defined as j of theta equals to summation of h of xi minus yi square, where I equals to 1 to m into 1 by m. As the difference between predicted value and actual value can be either positive or negative, and negative value will nullify positive value. It squared the difference to make them positive. Then the sum is multiplied by 1 by m to normalize. We are summing all the differences, and by dividing by m, it's kind of bringing back into individual level. Now we have to reduce j of theta by keep changing theta until we end up at minimum. In this graph, cost function is plotted at y-axis and theta on x-axis. We have to minimize j of theta, for which we are going to use gradient descent algorithm. Gradient descent algorithm is to gradually descending the error. Let's see the steps. First, we have to initialize theta with some random value. Then calculate the cost function. Next step is to calculate the partial derivative or gradient of cost function. After this, we are going to update theta's value. New value will be old theta's value minus alpha into gradient, which was calculated in previous step. Here alpha is called as learning rate, which defines how big a step we are taking in gradient descent. If alpha is very large, that means we are using very aggressive gradient descent procedure. And if alpha is very small, then we are taking very small baby steps. And step 5 is repeating step 2 to step 4 until convergence. Now we know what is cost function and gradient descent, using which we can train the model and predict the output. Let's go back to original sample dataset. We have more than one feature. Let's denote them as x1, x2, x3 and x4. How can we include all these features in our formula? Here linear algebra comes into picture. Using linear algebra, all the features can be represented into a matrix, also known as feature vector. and output values can be represented as a vector. For multiple features, linear equation can be written as y equals to theta 0 into x0 plus theta 1 into x1 plus theta 2 into x2 plus theta 3 into x3 plus theta 4 into x4, where x0 equals to 1. Theta can also be represented as a vector and model will be created through matrix operation like y equals to theta transpose x. So using gradient descent, we have minimized the cost function value and found the model. But can we really say that this model would work accurately for real data it has never seen before? No, right? So what's the solution? We need some kind of evaluation mechanism to make sure that our model has got the right pattern. Through cross-validation technique, we can validate our model. In cross-validation technique, we keep aside some set of data for validation named cross-validation set, and raised dataset is used for training purpose. But keeping a part of data aside for cross-validation may raise the risk of losing important pattern in the dataset. To avoid this risk, k-fold cross-validation technique was introduced. In k-fold cross-validation, data is divided into k subsets. Now each time one of the k subset is used as validation set and the other k-1 subsets are put together to form training set, and this is repeated for k times. This diagram is for k-fold cross-validation where k is 4. This is all for this session. If you have any queries, let me know through comments. Thank you.